Hi everyone. Today I'll be continuing with the topic matrices, in which today I'll be taking three examples basically or to explain you the concept of this property, commutative property of multiplication. Commutative property of multiplication which does not hold true. To explain it further, I'm going to take these three examples one by one. So let us start with the first example. Let A is equal to 1 0 0 minus 1 be a 2 cross 2 matrix, and B is equal to 0 1 1 0 be also a 2 cross 2 matrix. Then let us find out AB and BA. So in example number 1, AB is equal to 1 0 0 minus 1 and B is 0 1 1 0. Since both are 2 cross 2 multiplication, 2 cross 2 matrix, therefore multiplication is defined. And what is the order of AB? That order is also 2 cross 2. So first row with the first column, 1 into 0 plus 0, 1 into 0 is 0 plus 0 into 1 is 0. First row, second column. So first row, second column is 1 into 1 is 1 and 0 into 0 is plus 0. 2, 1. 2, 1 is 0 into 0 is 0 plus 1 into minus 1 is minus 1. Then 2 cross 2. 0 into 1 is 0. Minus 1 into 0 is again 0. So the resultant is 0, 1, minus 1, 0. This is AB. Let us find out BA. So BA is 0, 1, 1, 0 into A, 1, 0, 0, minus 1. This gives first row with the first column as 0 into 1 is 0 plus 1 into 0 is also 0. Then first row, second column, 0 into 0 is 0, 1 into minus 1 is minus 1. Then 2, 1, second row, first column, 1 into 1 is 1, plus 0 into 0 is 0. Then 2, 2, 1 into 0 is 0, 0 into minus 1 is also 0. 0 into minus 1 is also 0. So this result is 0, minus 1, 1, 0. This is 1 and this is 2. What do you find? Are you able to verify this result? Are you able to verify this result? Yes. AB is not equal to BA. This was first example, right? Let us do now second example. and see what happens. In the second example, A is 1, 0, 0, 2 and B is 3, 0, 0, 4. So AB is first row with the first column. 1 into 3 is 3 plus 0 into 0 is 0. 1, 2. First row, second column. 1 into 0 is 0 plus 0 into 4 is also 0. Then second row, first column. 0 into 3 is 0. 2 into 0 is also 0. Then 2 into 2. Second row, second column. 0 into 0 is 0. 2 into 4 is plus 8. So the resultant is 3, 0, 0, 8. Let us now go to BA. B is 3, 0, 0, 4, 1, 0, 0, 2. Let us do this. First row, first column, 3 into 1 is 3, plus 0 into 0 is 0. First row, second column, 3 into 0 is 0, plus 0 into 2 is also 0. Second row, first column, 2, 1. 0 into 1 is 0, 4 into 0 is also 0. Then 2, 2. 0 into 0 is 0, 4 2s are 8. So the resultant is 3, 0, 0, 8. So 1 and 2 implies AB is equal to BA, right? Now your anxiety starts. As I said, in this property, that commutative property does not hold true. It does not happen in the case of first example, but in the second example, this is not true. So what does it mean? So here you might have confusion that AB is not equal to BA, AB is equal to BA. So what should be the result? See, when we talk about any property, the property is verified only when it is verified in each and every condition. If it is partially verified and partially not verified, then the property does not hold true. That is the conclusion of these two examples. So these two examples are over. Now let us move to third example. Let us see. Let us start with the example number 3, AB. AB is equal to 0, minus 1, 0, 2 and 3, 5, 0, 0. So this is equal to first row, first column, 0 into 3 is 0, plus minus 1 into 0 is 0, 0 into 5 is 0, minus 1 into 0 is 0. Second column, second row, first column, 0 into 3 is 0, 2 into 0 is 0. Second row, second column, 0 into 5 is 0, 2 into 0 is. So what do you get? The resultant? A 0 matrix. What is the importance of this example and why I have chosen this example? The reason is, here you can see that A and B both are non-zero matrix. But what is the resultant of A and B? It is coming out to be zero matrix. So this is the best example to understand that the product of two non-zero matrix can result to a zero matrix, right? So these were three important things regarding this commutative property, three examples. Now I will start with the next topic, the fresh topic, which is called transpose. Transpose of a matrix. What is the meaning of transpose of a matrix? So let me define first the definition of this. So let A be a matrix defined as A is equal to Aij of order m cross n. Then transpose of a matrix is defined as A or AT. These are the two symbols for defining the transpose of a matrix. That is, A transpose is equal to A J I of order n cross m. To understand it in a better way, let us take an example. Let A is equal to 0, 1, 2, minus 3, 2, 5. Suppose this is an example of order 2 cross 3. So if I want to find out A transpose, then first of all, I need to understand that m cross n will change to n cross m. So here the order is 2 cross 3, so it will change to 3 cross 2. If you know this, your major problem is solved. Then what is the conclusion of these two? Part of definition, Aij will become Aji. So this is A11. So A11, since I is equal to j, it will remain here. This is A12, A12. So A12 will become 21. A13 will become. So basically what happens? The first row will become the first column. Then second is 2, 1. So 2, 1 will become 1, 2. 2, 2 will go to 2, 2 only. and 2, 3 will become 3, 2, 3, 2. So basically what happened? The second row will become second column. This is the procedure of definition part of transpose of a matrix, and this is how it happens. I hope you have understood it. Let us continue further with more on transpose of a matrix. Whenever we learn something new, we need to understand what other part is included in that. So in this, the next part comes, what are the conditions under which this transpose of a matrix is defined? That is called properties. See, properties has a big role to understand the concept, right? And if you understand the property, you will not stuck up anywhere, and it helps you in learning. So you need to understand. If you take the transpose twice, you will get back same. If you take the transpose 2 times, you'll get back Ka transpose, where K is a scalar. This scalar has nothing to do with this. Simply you write transpose and you can write K outside. The third is A plus B transpose. So A plus B transpose is A transpose plus B transpose. You can take the transpose on the sum, or you can take the transpose and then add one and the same thing. Then property number 4 is AB transpose. This is one of the important property which will help you later on in solving the multiplication concept in later part of matrices. So these are the 4 basic properties applicable on transpose of a matrix. To just try to understand quickly, let us take an example. A is equal to 3 root 3, 2, 4, 2, 0, and B is equal to 2 minus 1, 2, 1, 2, 4. And let us verify this, and this quickly. And if possible, let us take this also. Let us do it quickly. The first one is A transpose transpose. So what is this? This is 3 root 3, 2, 4, 2, 0 transpose, and then again transpose. So first let us solve inside. What do you get? This is 2 cross 3. So what will happen? It will become, as I told you in my example, previous example, first row will become the first column and second row will become second column. Let us do it first. Okay. So it becomes 3 cross 2, and the transpose, outer transpose will come again. And as you know, now the order is 3 cross 2, so it will become 2 cross 3. And when you take the transpose, the first row will become the first column, second row will become the second column, and the third row will become the third column. So what do you find? Is the property verified? Have you got it back as A? 3 root 3 2 4 2 0. Yes. So we got it back. So first property is verified, that A transpose is A. Okay. Now the second property. Let K is equal to 3. Let us define K as 3. Therefore, Ka transpose will become 3 times A, 3 root 3 2 4 2 0 and 4 transpose. So when you know the scalar multiplication, what will happen? 3 3s are 9, and this will become 3 root 3. This will become 6. 3 4s are 12. 3 2s are 6. 3 0 0 and transpose. That will become 9. First row will become first column, and second row will become second column. This is, call it 1. Now we need to verify right hand side. This is your left hand side. Now let us do right hand side. Ka transpose. So it will become 3 times A transpose. 3 root 3 2 4 2 0 transpose. First row 3 root 3 2 4 2 0. Second row will become second column. So what is the answer now? The answer is 9, 12, 3 root 3, 6, 6, and call it 2. So what do you find? This is 2 and this is 1. Would you find that this is verified? Yes. Ka transpose is equal to K times A transpose is verified. So second property is also verified. Now let us move to third part. The third property is, this is done, this is done, The third property is A plus B transpose. So let us talk about left hand side. Left hand side is A plus B transpose. Let me do it fast. 3 plus 2 is 5. Minus 1 plus root 3 is minus 1 plus root 3. 2 plus 2 is 4. 4 plus 1 is 5. 2 plus 2 is 4. 0 plus 4 is 4. And the transpose. Please check the answer. 3 plus 2 is 5. Root 3 minus 1 plus root 3. 2 plus 2 is 4. 4 plus 1 is 5. 2 plus 2 is 4. 0 plus 4 is 4. Fine. Answer is fine. Now you take the transpose. So you get 5 minus 1 plus root 3, 4. Again, same. First row will become first column. This is how I solve. So call it 1, left hand side. Right. Now right hand side is A transpose plus B transpose. So A transpose is 3 root 3 2 4 2 0. I have written directly, right? And B transpose is 2 minus 1. Sorry, 2 minus 1 2. First row will become the first column, and 1 2 4. So what is the answer? 3 plus 2 is 5. 4 plus 1 is 5. Minus 1 plus root 3 minus 1 plus root 3. 2 plus 2 is 4. 2 plus 2 is 4. 0 plus 4 is 4. So I hope you have understood by seeing that this implies 1 and 2 implies A plus B transpose is equal to A transpose. Verified. Now, to do the fourth case, I need to rub the whole thing. Till now, these first three properties were easy. If you try yourself, you can also. The whole exercise is having the problem based on verification of the properties only. So you can take a lot of exercise problem and try yourself. The fourth solution. Let us start with AB transpose. So AB transpose is what? You have to be careful when you are talking about AB transpose. So here you first have to check everything. This is 2 cross 3. What do you find? AB transpose. AB transpose. A, B, and this is also 2 cross 3. Right. So what was the property? That AB has to be valid. AB is defined. What was the condition for AB to be defined? What do you find? You find the number of column must be equal to number of rows. Is it same? So what do you find? This is not defined, right? Let us see what about right hand side. What happened about right hand side? Right hand side is AB is not defined. Since AB is not defined, so transpose, how you will define? Look at this. AB, the number of column in A is 3 and number of rows in B is 2. Number of rows are 2 and number of columns are 3. So that is why AB is not defined. Since AB is not defined, that's why the transpose is also not defined. Let us talk about B transpose, A transpose. What is B transpose? B transpose is 2 minus 1, 2, 1, 2, 4. This is 3 cross 2. And what is A transpose? A transpose is 3. So number of column is not equal to number of rows. So this is also not defined. Why? What is the interesting part about this not verification? What is the important part? What do you concluded about this? That if you want to define, that is why I said this property is very important for you. To talk about AB transpose equal to B transpose A transpose, you must verify that AB is defined and this is defined. If this is not defined, then property will not be verified, right? But later on we'll see if we come across any example, we will try to show you that AB transpose is equal to B transpose A transpose where this condition is verified. Okay, let us move further with more on transpose. More on transpose. There are two divisions of transpose of a matrix. One is symmetric matrix and the other is skew symmetric matrix. Let us define. Let A be a square matrix. Then A is said to be a symmetric matrix if A transpose is equal to A. Simultaneously let us. You can also form yourself. A transpose is equal to. The first most important thing is what? It has to be a square matrix. So I am taking an example of 3 cross 3. You can form yourself 1, 2, 2, 3, 5, 2, 3, 5, minus 1, minus 1. See what I am doing. 4, 4, 6, 6. I hope you have understood what I have done. I have first fixed the main diagonal elements, then across the main diagonal elements, I have put the same elements. You will understand what is going to happen. When you take A transpose, what will happen? Since it is a 3 cross 3, so there will be no change. That is the purpose. There is a condition that it has to be a square matrix. Then only this condition will be verified. Now what do you have to do for taking the transpose? The first row will become the first column. So 2 minus 1, 4, 2 minus 1, 4. Second row will become the second column. Third row will become the third column. So what do you find? What do you find? The main diagonal elements are same, and across the main diagonal you find the same. So this is same as A. This is the beauty of this property, this definition, that you can generate yourself. I have given you the trick how to form a square matrix which on taking the transpose will give you A back. So if you take these elements same across the main diagonal, when you take the transpose, you will get back same. Now let us come to skew symmetry. What is skew symmetry? Definition says let A be a square matrix, then A is said to be skew symmetric if A transpose is equal to minus A. This is important. Look at the example, what I am going to do. You will be surprised to see the example. When I'll take a 3 cross 3 and see what happened. Fix the elements on the main diagonal as, I'll give you the reason why I have taken 0, 0. Then across the main diagonal, you take 1, minus 1, minus 2, 2, minus 3, 3. Take the element in such a way that their sum is 0. So what will happen when you take the transpose? When you take the transpose, what will happen? 1, when you take this, what will happen? The first row will become the first column. So 0, minus 1, 2, 103 will become 103, and minus 2, minus 3. So what is this? Take minus common, and what will happen? 0 will remain 0. I am speaking, 0 will become 0, 1 will become minus 1, minus 2 will become 2, minus 1 will become 1, 0 will become 0. If minus 3 will become 3, this 2 will become minus 2, 3 will become, what is this? Is this A? Yes, this is A. I'll just change and see what happens. I will not do much change. I will show you why these zeros are important. Let me change this and make it 5. So what will happen? 0 minus 1, 2 is fine. 1, 5, 3. This will become, and when you take minus, because you have to bring this minus out. So the moment you take minus common, what will happen? What will happen? The moment you take minus common, what will happen? 0, minus 1, minus 2, minus 1, and here when you take minus common, this will become minus 5. Will it be equal to A? Look at this. It will not be equal to A. I have done just one change, and you can see that this condition, this definition is not satisfied. That is the reason why we need to take this. Now I'll give you the mathematical reason why these are taken as 0. I'll explain you here. I'll rub this so that you don't have any confusion. Look here, when you say A transpose is equal to minus A, what are these elements? These are all AII. So what happened? AII is equal to minus AII, because if you take A11 transpose, you will get back 1 only. You take 2 you will get 2 only. They will not change the place. So 1 will remain 1 2 will remain 2 3 will remain 3. You can see. You can see. When you take the transpose, 1 will remain 1 2 will remain 2 and 3 will remain 3. Right? They will not change the place. Rest of the element will change the place. So what happened? According to that definition, when you take transpose, A11 will become A11, A22 will become 22, A33 will become 33, and it will be equal to minus AII. So when you solve this, what happened? 2AII is equal to 0, which implies AII is equal to 0 for all i's. All right. That is the reason, that this is a mathematical reason to take these elements as 0 when you are talking about skew symmetric matrix. I hope the thing is clear to you. Just few minutes more. To wind up with this topic, transpose of a matrix. I hope this is clear. Now, few results I need to discuss based on this. So, the first result is our result 1. For any square matrix A with real number elements, your element should be real. Real number element means your element must be real. A plus A transpose is always symmetric. and B, A minus A transpose is always skew symmetric. If you want me to explain further, you just send me, just write in the comment box that you want this part to be explained further. Because sometimes they ask you to prove in board exam. So if you need to understand this in detail, you can just write the comment request in the comment box. So result number 2. Any square matrix can be expressed as the sum of asymmetric and a skew symmetric matrix. That is, A can be written as half A plus A transpose plus half A minus A transpose. This is your P and this is your Q. This is symmetric from previous discussion here, and this Q is skew symmetric, as you can see from here. So any matrix A can be expressed as sum of symmetric and skew symmetric matrix. In my next lecture, I will be continuing with transpose of a matrix, and I will take the example of these two results. Thank you very much. You go through the video, and if you like, you share it and subscribe my channel so that you can get the best on matrices. Thank you very much.